So we have the other part of kinematics, projectile, and this is from the ground level, whereas this is from the top level. Here will be, in projectile, horizontal component is always constant. Horizontal component is always constant, and there is change in the vertical component due to g. So in this oblique projection, a body is thrown with velocity u, making an angle theta with horizontal. R is range, h is height. Similar in case of this is the height. A body is thrown from height h with velocity u, and it travels range r. So now in this case, x component will be, y component will be u sin theta, and x component will be u cos theta. So x distance is equals to u cos theta into t, whereas y component is equals to u sin theta into t, minus, from here on it will go on decreasing, so it will be minus half gt square. Now putting the value of t in this equation, we will get u sin theta into x by u cos theta minus 1 by 2 g into x square u square cos theta y is equals to this. This is the required equation of this projectile. Similarly, in case of this, x component is u and y component is u into t minus half, so it will go on decreasing by half gt square into d. So putting value of t, oh yeah, here distance is h, velocity is equal to distance traveled by time taken, so distance is equal to velocity into time, so it will be h minus half gt square. So now putting the value of t here, you will get h minus 1 by 2 g u square by x square, y is equal to, this is the equation in case of horizontal, but this one is important equation. And time of flight, t is equal to 2u sin theta by g, and horizontal range r, a and g, e range, this r is equals to u square sin 2 theta by g, and then we have maximum height h is equals to u square sin square theta by 2g. These are the three important formulas you need to remember, and then just you have to put 90 degree here. So here we don't have theta, and time will be, I did a mistake. Here we have time of flight, t is equal to root under 2h by g, and then horizontal range we have u root under 2h by g. So these are also to be known. There is this other thing you need to learn at highest point and at final point. So at highest point, velocity is equals to u cos theta, and here velocity is equals to u. This is in case of oblique motion here. And then we have L, moment, mu cos theta into h max. Here L we have mu into r sin theta. This is angular momentum. I have forgotten linear momentum. So linear momentum P is equals to mu cos theta here, and here P is equals to mu. Then we have change in angular momentum is equals to mu sin theta. Here change in angular momentum is equals to 2 mu sin theta. Here torque is equals to mg into r by 2. Here torque is equals to mg into r. Here kinetic energy is equals to E naught cos square theta. Here kinetic energy is equals to 0. Here potential energy is equals to E naught sin square theta. Here potential energy is equals to 0. So these are the things you need to learn by heart in projectile. There is also a case in projectile where a passenger. So let's take a case. Here is a train and here is a passenger. So now a passenger drops a body in a uniformly moving vehicle. So he drops it. The trajectory would appear straight line. So passenger will think it as a straight line. But if a person is on the ground outside watching, then you will look out, person will see is going in a parabolic path. Continuing with the case. So here is a case. Your body is thrown with velocity u, and at a point it reaches a point where if you make imaginary line, it will make a perpendicular with the angle of projection, this. Then here the velocity will be u cot theta. So here it will be u cot theta. So now talking about when a body is thrown from an inclined plane of inclination b. So a plane is inclined b, and then making an angle alpha, a body is thrown like this upward. Then time of flight is equals to 2u sin alpha minus beta by g cos beta, and r range is 2u square sin alpha minus beta cos beta by g cos square beta. So it looks like 2u sin theta by g, but here you have to add cos theta, and here range is 2 u square sin square theta by, so it won't, you won't, but here it is 2u sin theta by g, and you have to have cos beta. Now the third, h. Horizontal range h is equals to maximum height h is equals to u square sin square alpha minus beta by 2g cos beta. So it also looks similar. U square sin square theta by 2g, u square sin square theta by 2g, 2u sin theta by g. You have to add cos beta here also cos beta. Here also you have to add cos beta. Here also you have to add cos beta. So yes, if a body is thrown from here with velocity this or dropped, then time of flight is equal. This you have to remember. Yes, it's this much. Keep tuned for more videos.